Hello, am I audible to all?
Yes, sir.
Okay. See, we will directly perform the practical because we have already explained this practical many times by using VLab also, by using in the theory. We will perform this practical today. See, what is the aim of that practical? The aim of that practical is nothing but to determine the parameter, that is equivalent circuit parameter of a single phase transformer by performing open circuit and short circuit test. OC test आणि SC test आपल्याला काय करायचे, परफॉर्म करायचे. By performing OC test and SC test, we want to determine the equivalent circuit parameter. So do you know that by performing OC test, that is by performing open circuit test, we are able to determine the equivalent circuit parameter, that is no load parameter. Also, we people know the no load losses. So no load parameter, that means we are able to calculate the value of no load current. After that, we are able to calculate the no load magnetizing current, that means no load component, magnetizing current, as well as working component, that is IW and IMU. After calculating IW and IMU, we are able to calculate the no load resistance, that is R0, and the no load reactance, that is X0. Okay. Now, when we conduct the short circuit test, that means secondary of the transformer, it can be short circuited by connecting one of the rigid wire or by connecting one of the solid wire. We are directly short circuit the secondary terminal of the single phase transformer. Single phase transformer चे आपण secondary circuit काय करतो, close करतो, that is short circuit करतो. Once the current, it can be rated current of the transformer, if it is flowing from that short circuited terminal, then we will note down the reading, that is short circuited voltage Vs, short circuited current Is, and the power taken at the time of short circuit test. So this power taken at the time of short circuit test, that is PCU, or we can represent that WCU. So this is nothing but the copper losses of the transformer. Okay, and once we people know the copper losses of the transformer and core losses of the transformer, we are able to calculate the efficiency also, as well as we are able to determine the equivalent circuit parameter. Again, by performing short circuit test, the equivalent circuit parameter, like as a equivalent resistance referred to secondary side, equivalent resistance referred to primary side, and equivalent impedance referred to secondary side, we are able to calculate, or it may be any one of the side we are able to calculate. And once this resistance, it can be calculated, then also we are able to calculate the regulation of the transformer and efficiency of the transformer also. I have already tell the formula for that in the previous one. Already मी तुम्हाला formula सांगितलंय theory मध्ये. So just we will perform this practical today physically. Don't wasting the time for discussing regarding theory, because we have already discussed it many times. I think 3 to 4 times we have discussed regarding open circuit and short circuit test. But this test is important. So in the view of the importance of this test, I have taken this test on physical also. We will taken. So see here, if you people are having the circuit diagram of that ओपन सर्किट आणि शॉर्ट सर्किट टेस्टची जर सर्किट डायग्राम असेल तर तुमच्या पुढे बघा घ्या, or if you have any screenshot, then see that. See, in case of circuit diagram, there are single phase supply is there. So single phase supply, we required positive and negative terminal. After that, this positive and negative terminal, it is connected to one of the auto transformer, so that we required one of the auto transformer. What is auto transformer? What is mean by auto transformer? Auto transformer, it is why it is used here? Connection diagram आहे का तुमच्याकडे? Otherwise I will see. Why the auto transformer is used? What is the function of auto transformer? We have already covered. Okay, see, this is the diagram. AC supply, that is positive and negative terminal single phase AC supply is required for conducting open circuit test. It is given to that of auto transformer. That means by use of auto transformer, we are applying the variable voltage. That means we are vary the output voltage of that auto transformer. See, after that auto transformer, one of the voltmeter is required to measure the supply voltage. So to measure the no load value of current, we required one of the ammeter. After that, one of the wattmeter is required to measure the no load power. And then it is connected to primary winding of the single phase transformer. So see, in the secondary side, the secondary terminal of the transformer, it is open circuited. Secondary side la secondary terminal जे आहेत transformer चे, these are the open circuited terminal. Okay, open circuited terminal, that is open circuited terminal secondary side, so that we can call it as a open circuit test of the transformer ची open circuit, त्याच्यामध्ये आपण secondary side जे आहे directly open करतोय किंवा open circuited put करतोय. And after putting this secondary side of the transformer open, we are able to calculate the no load losses. See, this voltmeter, it will show the supply voltage. This ammeter, it will show the no load current taken by the primary winding of the transformer, because secondary side there is a zero current will be flowing. Okay, so here I0, and this wattmeter shows that the no load power. Wattmeter काय करेल? No load power show करेल. Okay, so see, I will see the connection diagram. This positive terminal, it is connected to auto transformer. Again, negative terminal, it is connected to auto transformer. See, one terminal of the auto transformer, it can be connected to one terminal of the ammeter. Next terminal of the ammeter, it can be connected to the M terminal of the wattmeter. After that M terminal, M and L, that means here it is current coil is there, one of the pressure coil is there. So MC gets short, and the L terminal, it is connected to one winding of the transformer. Primary winding चे एका terminal ला connect केले. Next terminal of the primary winding, it is connected to negative supply. Again, one of the voltmeter is required to measure the supply voltage. Okay, so see, we will do the connection. I will show you connection, that much. See, here it is positive, and that is here it is three-phase supply. We required single phase supply, so we are taking one positive L terminal, that is R phase, and neutral terminal. Okay, so this is nothing but it will be a single phase supply. So here single phase supply is given. Now I will connect it to single phase supply. Okay, so positive terminal, and here it is neutral terminal, or it may be negative. Okay, so see, these are the auto transformer terminal or auto transformer wire. I have connected it to auto transformer. Now see, there are two terminals of the auto transformer, one positive and one negative. दोन terminal आहेत. One terminal of the transformer, it can be connected to the one terminal of the ammeter. बघा, ammeter च्या एका terminal ला connect केले. Next terminal of the ammeter, ammeter चे जे काही next terminal आहे, so this terminal of the ammeter, it can be connected. कुठं connect केले बघा. So it can be connected here. Here it is. Okay, see, next terminal of the ammeter, it can be connected to M terminal. बघा इथं connection केलं आहे. It is connected to M terminal of the wattmeter. Wattmeter चे M terminal आहे. Now M terminal and C terminal of the wattmeter, this M and C are common terminal. That means दोन्ही short केले बघा मी इथं M आणि C. So these two terminal are short circuited. Now the L terminal of the wattmeter, it is connected to the one terminal of the primary winding. Primary winding चे एका terminal ला connection आहे याचं. See, we will connect this one to the one terminal of the primary winding. So see, this is the transformer, single phase transformer, whose primary winding, whose secondary winding. So secondary winding here having a number of tappings are there. That means, so these are the number of tappings having an see here 0% to 100%. If it is connected, then 100% winding it will be connected. If it is connected here, then 86.6% winding is connected. If it is connected here, then 50% winding it can be connected. If it is connected here, then 33% winding is connected. Okay, like that. That means there are tapping are provided on secondary side. See, the L terminal of the wattmeter, it can be connected to positive terminal of the primary winding. Primary winding चे एका terminal ला connect केले. Next terminal of the primary winding. Primary winding चे जे काही next terminal आहे, it can be connected to V terminal of the wattmeter. Wattmeter च्या V terminal ला connected आहे. Then V terminal of the wattmeter, it can be connected to negative supply of the auto transformer or the negative terminal of the auto transformer. And negative and positive it can be connected to directly supply. See, on open circuit test, instead of keeping this secondary circuit open circuited, we are just measuring the open circuited voltage or induced EMF at the secondary side, so that we have put here one of the voltmeter. इथे एक voltmeter काय केलंय, put केलंय to measure the secondary side voltage. Secondary side voltage measure करण्यासाठी मी एक voltmeter काय केलंय, connect केलंय. Okay, so these are the simple connection. Secondary side is open circuited, so the open circuited terminal current flowing from that is nothing but 0, and the some of the induced EMF it will be present in the secondary side. So to measure that induced EMF, no need to connect also, but we are measuring the voltage. नाही connect केलं तरी पण चालेल. Okay, so see, secondary voltage, it can be secondary induced voltage, it will be shown by this voltmeter. This wattmeter shows the reading of power taken at the no load condition. This ammeter, it will be shows the reading, that is no load current taken, and then this voltmeter, it will be shows that the supply voltage reading. So this is the open circuit test connection. Okay, open circuit test connection. लक्षात आलं काय connection? All of you getting? Hello.
Yes.
Okay. Can we perform? Perform करूया का?
Yes, sir.
Okay. See, check the initially this that means auto transformer, it is having a 0 position. We are gradually varying this knob, or by varying this terminal, we are increasing the supply voltage across this transformer. And once the supply voltage, it will be reached to that of rated value. So rated value upon 230 volt देणार आहे. At that situation, we will check the no load current taken from the transformer, from the supply voltage of the transformer, and after that we will check the no load power. त्याची no load power काय करणार, check करणार. Okay, see, I will just switch on. Okay, see here one LED, it will be glow. That means this auto transformer, it can be connected to single phase supply. Supply ला connect झालेलं आहे बघा. Now we are gradually varying this auto transformer and increasing the primary winding voltage. मी काय करतो, gradually vary करतो. So we are increasing the voltage. We will give the voltage near about 230 or 220. Okay, see at that situation, this voltmeter, it will be show some of the reading, that is supply voltmeter. Supply side चा voltmeter जो आहे तो काहीतरी reading दाखवतो. किती आहे? All of you read this value. किती आहे? Read the value of voltage.
110.
110. Scale where I have connected. कनेक्शन कितीला आहे? See here, common point is here. I have connected it to 300. So scale for 300. This 110, 120, 140, and 150. So this scale below scale for 150 connection. I have connected it to 300. So double of that. That means 110 into 2. किती झालं?
200.
100. 220 na?
Yes. Yes, sir.
Okay, see all of you take reading. No load voltage, it is nothing but 220 volt. Now the ammeter, it will show some of the reading. Ammeter je ahe, it will also show some of the reading. That means it is nothing but 0. AC voltage दाखवले बघा. AC voltage, sorry, AC current 0.291. All of you take this one, 0.291. 0.29 and 1. Okay. Now here wattmeter is also showing some of the reading. That means no load power taken by the wattmeter. Wattmeter ने घेतलेली power no load condition ची किती दाखवते हे बघा. दिसतंय का? किती आहे? See, in between 0 to 25, there are 10 lines. Up to that, half of 25 is nothing but 12.5. इथपर्यंत काय येईल? 12.5. 12.5 मध्ये परत किती लाईन आहेत? 4 lines. That means 5 lines. What is the value of one line?
20. 2.5.
2.5 watt. Okay. See, 2.5 watt. This scale is for कितीपर्यंत scale 150, 175, 185. So this scale is for 150. I have connected it. किती voltage ला connect केलंय मी? कितीला connect केलंय? Voltage
300.
300. So multiply by 2. Okay. So multiply by 2. 2.5 into 2, it is nothing but 5 watt. Okay, 5 watt. So this is nothing but no load power taken from the supply. So it will take a minimum amount of power, or it will take a less power, because only power is required for only overcome the no load losses. No load losses म्हणजेच P input at no load condition is nothing but no load losses of the machine. That is PI. That is iron loss, or we can call it as a core losses of the transformer. Okay. See, secondary side, there is some of the voltage it can be induces. Secondary side ला काहीतरी voltage induce होतंय. किती value आहे? किती आहे value? Secondary side ला induce होणाऱ्या voltage ची value in between 40 and 50, near about 45. So 45 into 45 into I have again here connected 300. 150 ला connect केलं नाही मी, 300 ला connect केलंय. So 45 into 2, it is nothing but 90. Okay. So near about 90 volt, it is nothing but induced voltage at the secondary side. Okay. Secondary side चे induced voltage काय आहे? 90 volt. So this is the simple no load test. It can be conducted on a single phase transformer. We have taken the reading of no load voltage. We have taken the reading of no load current taken from the supply, and we have taken the no load power. Okay. त्याच्यावरून आपण no load power चे reading पण काय केलेले घेतलेले. Now see, there is one of the concept of multiplying factor. एक multiplying factor चा concept असतो बघा. I think you people know or don't know. Whether you people know the multiplying factor? मल्टिप्लाइंग फॅक्टर माहिती आहे का तुम्हाला? Hello, whether you people know the multiplying factor concept? See, multiplying factor, it should be depends upon rating of current and the voltage. Current च्या आणि voltage rating च्या wattmeter च्या current आणि voltage rating वरती depends असतो. Okay, so again multiplying factor is nothing but the reading, it can be multiplied to that factor, then we will get the actual reading. That's आपल्याला actual reading मिळतं. So see, we have connected it for 300 and we have connected it to measure the current of 20 ampere range. It can be connected to 20 ampere. So multiplying factor for that, त्याच्यासाठीचा multiplying factor जे आपण वॅटमीटर न शो केलं रीडिंग होतं 5 वॅट 2.5 आहे, त्याचं 2 न मल्टिप्लाय केलं 300 चं स्केल आहे म्हणून इट इज नथिंग बट 5 इंटू मल्टिप्लाइंग फॅक्टर अगेन 5. So it is nothing but 25 watt PI आला. Okay, 25 watt PI 0.285 और किती होतं 2829 होतं का मगाशी घेतलेलं रीडिंग 0.29 और 28 घ्या. करंट and the voltage, it is nothing but 220 volt. Okay, so these are the reading of no load condition or open circuit test. हे open circuit test चे reading आहे. Okay, so I will reverse procedure. I will kept this auto transformer to 0 position. Auto transformer with 0 position ला. Then I will switch off the supply. All of you getting open circuit test? Current taken from the supply, it is near about 1% of the rated current. Rated current च्या 1% असतो, ते मी आपण पाठीमागच्या एक्सप्लेनेशन मध्ये सांगितले. All of you getting open circuit test? We want to conduct short circuit test on the similar setup. Open circuit test लक्षात आली का?
Yes, sir.
Okay, now we will conduct the short circuit test. Again, for conducting short circuit test, the change is that the secondary terminal, हे जे काही secondary terminal आहे, just short circuit that terminal. So I will remove the voltmeter which are connected in the open circuit test. Open circuit test मध्ये कनेक्ट केलेला जो काही voltmeter आहे तो मी remove करतो and I will connect or I will short circuit this terminal. Okay, short circuit is nothing but directly these two terminal are short circuit. बघा एक टर्मिनल मी इथे कनेक्ट करतोय सेम वायरचं, नेक्स्ट टर्मिनल जे आहे नेक्स्ट टर्मिनल ऑफ द सेम वायर इट इज कनेक्टेड हियर. Okay, see, I have connected or I have directly put a short circuit. दोन टर्मिनल काय केले शॉर्ट सर्किट. Okay, see, in case of short circuit test, the secondary it can be short circuited. जे काय secondary terminal आहे ते secondary terminal आपण काय करतोय short circuit करतो. Once the secondary terminal it can be short circuited, how this test it can be conducted? So test it can be conducted so slowly or gradually applying the supply voltage. Gradually applying the supply voltage, we are gradually applying the supply voltage. We are just flowing the rated current to the transformer. ट्रान्सफॉर्मरचा रेटेड करंट फ्लो होईपर्यंत आपण काय करतोय, त्याच्यामधून करंट फ्लो करतो, and we are taking the reading of copper losses or it may be power taken at the short circuit test and short circuiting voltage. शॉर्ट सर्किटचं व्होल्टेज आणि पॉवर काय करतोय आपण टेक करतो. सी सेकंडरी टर्मिनल इट कॅन बी शॉर्ट सर्किट. हे जे काय सेकंडरी साइडचे टर्मिनल आहेत ते काय केले आहेत, मी डायरेक्टली शॉर्ट सर्किट केले. ओके बघा, नाउ वी आर ग्रॅज्युअली अप्लाइंग द सप्लाय व्होल्टेज. आता आपण मगाच्या टेस्ट मध्ये डायरेक्टली रेटेड व्होल्टेज अप्लाय केलं होतं, राईट नो. रेटेड व्होल्टेज अप्लाय केलं ना ओपन सर्किट टेस्ट मध्ये. यस, गिव्ह मी रिप्लाय. ओपन सर्किट टेस्ट मध्ये आपण काय केलं, रेटेड व्होल्टेज अप्लाय केलं. दॅट मीन्स 220 और 230 व्होल्टेज आपण व्हॅरी केलं, ते अप्लाय केलं आणि ओपन सर्किट टेस्ट घेतली. नाउ इन केस ऑफ शॉर्ट सर्किट टेस्ट, अप्लाय सच व्होल्टेज टू फ्लो अ शॉर्ट सर्किटेड करंट. शॉर्ट सर्किटेड किंवा रेटेड करंट फ्लो होईपर्यंतच आपण व्होल्टेज अप्लाय करतो. सी द ट्रान्सफॉर्मर इट इज हॅव्हिंग एन हाऊ मच केव्हीए ट्रान्सफॉर्मर. किती केव्हीए चा ट्रान्सफॉर्मर आहे? 1000 VA चा आहे. 1000 VA is nothing but 1 kVA. Okay, suppose having an if we are consider the this transformer having an unity power factor. जर याचा पॉवर फॅक्टर काय आहे, युनिटी आहे असं कन्सिडर केलं, राईट नो. सी द पॉवर फॅक्टर इट इज नथिंग बट युनिटी. याचा जर पॉवर फॅक्टर आपण युनिटी कन्सिडर केला, सी हियर, सी the what is the formula? P is equals to V into I, that is kVA. So it is nothing but 1000 is nothing but V into I, or VI cos phi, it is equals to 1000 cos phi. If we consider one, so we can represent it is VI is equals to 1000. Suppose supply voltage of the transformer is 230, current I it is equals to, we want to calculate, I is equals to 1000 divided by 230. किती येईल करंट, रेटेड करंट 1000 divided by 230. What is the value of rated current? Near about 4 point something येतोय ना.
4.34.
Okay, so near about 4.34 or 5, so that we can represent the rated current of the transformer is nothing but 5 ampere. Okay, so we are passing less than 5 ampere current, that is rated current च्या below current आपण काय करतो, flow करतो, and we are conducting the short circuit test because we are secondary terminal, we are short circuited. Secondary terminal short circuit केले. If the current flowing from the secondary winding, if it is greater than 5 ampere, जर आपण rated current पेक्षा जर जास्त current flow केला, then the winding of the transformer it may get damaged. Winding काय होऊ शकते, डॅमेज होऊ शकते ना. हॅलो,
Yes, sir.
winding of the transformer it may get damaged. So we are flowing the rated current or less than rated current. रेटेड करंट किंवा त्याच्यापेक्षा कमी करंट काय करतोय आपण फ्लो करणार ट्रान्सफॉर्मरच्या प्रायमरी आणि सेकंडरी वाइंडिंग मधून. ओके, सेकंडरी आणि प्रायमरी वाइंडिंग मधून ट्रान्सफॉर्मरच्या रेटेड करंट फ्लो होईल एवढा करंट जाईपर्यंत जे काय व्होल्टेज असेल तेवढं व्होल्टेज अप्लाय करणार. सो दिस इज नथिंग बट शॉर्ट सर्किटेड व्होल्टेज, शॉर्ट सर्किटेड करंट and the power taken at short circuit condition. शॉर्ट सर्किट कंडिशनला वॅटमीटर ने घेतलेली पॉवर. सो त्याचे एक रीडिंग घेतलं की short circuited voltage is here, short circuited current is here, ISC is here, and the WCU or PCU, WCU किंवा PCU. So it is nothing but copper loss. याच्यावरून आपण R01, X01 आणि Z01 कॅल्क्युलेट करू शकतो. Again from this copper loss we are able to calculate the efficiency also. त्याची efficiency पण कॅल्क्युलेट करू शकतो. Okay, so see I will show, we will conduct the test. See here, at that situation, what is the value of current? Current ची किती व्हॅल्यू आहे सध्या?
0.08.
0.085 आहे. एवढा करंट म्हणजे रेटेड करंट, बिलो रेटेड करंट, दॅट मीन्स समवॉट वी आर टेकिंग रिडिंग ऑन 4 एम्पियर. आपण 4 एम्पियर ला रिडिंग घेऊया. सो दॅट मीन्स लेस दॅन रेटेड करंट वी आर अप्लाइंग द व्होल्टेज. हा 4 एम्पियर जोपर्यंत फ्लो होतोय तोपर्यंत आपण व्होल्टेज अप्लाय करणार. Once the 4 ampere current or the rated current, it will be flowing from transformer, we will stop. That means varying the rheostat. See, I will vary the rheostat. Rheostat मी vary करतोय. बघा. Okay. Okay, see. Current किती flow होतोय आता? 4.2878. That means we have conducted this test on rated value, that is 4.272 ampere current. It will be flowing from transformer. Transformer मधून 4.27 or 26 ampere current it will be flowing. See, at the time of voltage, that is short circuited voltage. Short circuited voltage. See the reading. I think whether you are visible, no? Yes, visible. Tell me the value of voltage. किती आहे reading? What is that reading? Hello? Give me
20.
reply immediately.
20, sir.
20 volt voltage, but I have connected it to 300. So 20 into multiply by 2. That means 40 volt. So see, at 40 volt of voltage, when I am short circuited the secondary terminal of the transformer, then there is a rated current, it will be flowing. त्या condition ला rated current काय होतोय? Flow होतोय. So see, all of you take the reading. VSC, that is short circuited voltage. V suffix see the reading of wattmeter. Wattmeter, it will also show some of the reading. किती आहे?
2.5.
2.5 आहे का? See, 0 to 25, in between that there are 10 lines. Up to this middle line it becomes half, 12.5, and 12.5 मध्ये 5 lines आहेत. Now the value shows it is nothing but 2 lines. 2 line ला value दाखवते, पहिली आणि second one. What is that?
5, sir.
5. So 5 watt we have connected to 300. So multiply by 2, it is nothing but 10 watt, and multiply by multiplying factor. 5 ampere साठी is the multiplying factor 5. Okay. For multiplying factor 2, 10 into 2. 10 into 2, it is nothing but 20 watt. So 20 watt, it is nothing but WSC, or we can call it as a copper losses, PCU or WC. काही लिहा तुम्हाला माहित असेल ते. PCU, WCU or copper loss. See, in case of short circuit test, at the minimum value of voltage, we get the rated current, it will be flows from transformer. Transformer मधून कमी voltage ला किंवा short circuit voltage ला rated current flow होतोय. So that voltage is nothing but short circuit voltage. That current is nothing but short circuited current, and the power taken at the time of short circuiting, it is nothing but PCU or the copper losses. ते काय झाले copper losses. Okay, so this is the short circuit test. Just we have short circuited this secondary terminal. Secondary terminal short circuit झाले. Now see, primary winding मधून पण same current flow होतोय, secondary winding मधून पण same current flow होतोय. Primary winding it is having and it will carry a 4 point something ampere current. Secondary winding, because it is short circuited, secondary winding it will carry some of the current. Can anyone tell me the voltage across short circuited terminal? Voltage किती आहे short circuited terminal च्या across? किती असतं? शॉर्ट सर्किटेड टर्मिनलच्या अक्रॉसचं व्होल्टेज, म्हणजे या दोन टर्मिनलच्या अक्रॉसचं व्होल्टेज म्हणतोय मी. इथं जर मी व्होल्टमीटर कनेक्ट केला, काय दाखवेल ते? दोन टर्मिनल जर शॉर्ट सर्किट आहेत, किती असतं व्होल्टेज त्याच्या अक्रॉसचं?
230.
किती वेळा मी सांगितलं ऑलरेडी. ओपन सर्किट मधला करंट किती असतो? ओपन सर्किट टर्मिनलच्या अक्रॉस करंट किती असतो? एखादी लाईन किंवा एखादी वायर ओपन आहे म्हणजे दोन्हीच्या मध्ये स्पेस आहे, कनेक्ट नाहीये, किती असेल करंट?
0.
In case of open circuit, current becomes 0 but voltage present. In case of short circuit, the voltage becomes 0, current it will be present. Short circuit terminal मधून फ्लो होणारा करंट काय आहे? 4 point something आहे. या दोन टर्मिनलच्या अक्रॉस जर मी एखादा व्होल्टमीटर कनेक्ट केला, it will show the 0 reading. Okay, so this is the short circuit test. I will do the reverse procedure. I will keep at the minimum position and I will stop this. Okay, see, this is the short circuit test. We have taken the reading of short circuited voltage, short circuited current, and also we have taken the reading of PCU or it may be WCU. Okay, and also we have conducted the open circuit test, taken the reading PI, I0 and V0. Okay, so and also I have explained the calculation part. All of you do the calculation and find out the equivalent circuit parameter and efficiency of the transformer. Transformer ची efficiency आणि equivalent circuit parameter, that is value of R0, value of X0, then value of Z0. Also calculate the value of R01, that is equivalent resistance referred to any one of the side, equivalent reactance referred to any one of the side, as well as equivalent impedance referred to any one of the side. Okay, getting? I think all of you getting OC and SC test, because we have discussed this test in 3 times while discussing regarding theory. After that we have discussed by using VLab, and also today we have discussed by physical. Okay, is there any doubt? कोणाला काही डाऊट आहे का याच्यामध्ये? Give me reply immediately.
No, sir.
Okay, so all of you do the calculation part and calculate or determine the efficiency, calculate the equivalent circuit parameter, and write it into manual. So in this way we will conclude this today's practical, and we will stop here. Thank you. Hello. Who is host? होस्ट कोण आहे? Harshvardhan is there? Okay. We will conclude and we will stop. Thank you.